Welcome to qnawire.
To conduct the hypothesis test for the change in the proportion of hotel rooms occupied over the 1 year period, we can use a two-sample z-test for proportions. The null hypothesis is that the population proportion of rooms occupied for the current year, which we'll call P1, is equal to the population proportion of rooms occupied the previous year, which we'll call P0. The alternative hypothesis would be that the proportion of rooms occupied for the current year is greater than the population of the rooms from the previous year, so P1 is greater than P0. The estimated proportions, P hat 1, would be the 1428 out of the 1700. Which we want. I did not do these correctly. If P1 is the current year and 2 is the previous year, then it would be I see how this is done now. This would be P1 minus P2. Again, this would be equal to 0 and greater than 0. Or in fact, this might even be less than or equal to 0 to be completely different. I don't know. I think you should leave this at equal 0. All right, so now then to two decimal places, P hat 1 for the current year is .84, and P hat 2 is 1360 out of 1700. Which is 0.80. And now we want the p-value. Well, first we need a z-test statistic, and that's going to be 0.84 minus 0.80 divided by the square root of the pooled proportion. Which is going to be the 1360 plus the 1428 out of the 1700 and 1700. So that's going to be 0.82. 0.82 times 1 minus 0.82 times 1 over the sample sizes. This calculates to 3.0355. And now we want a p-value. And you can do this from a z-score, you can do this from a z-table, which is a standard normal table, or a calculator. But if we have a z-score of 3.0355, and we're testing this, well, we'll get that to a minute, but this is going to be one-tailed. This gives us a p-value, and we want this to 4 decimals. I see this as 0.0012. Using a 0.05 level of significance, we would reject the null hypothesis in favor of the alternative. The 95% confidence is going to be the difference between the proportions, which is 0.04 plus or minus the critical z for 95%. That's going to be 1.96. And that's going to be times the square root of the pooled proportion times 1 minus the pooled proportion times 1 over those reciprocal sample sizes. And we want this to 4 decimal places. Let me get that into the calculator. The lower boundary would be from subtracting. And that would be 0.0142 to the upper boundary from adding 0.0658. And officials, do you think area officials would be pleased with these results? I would generally say yes, and that's because 0 is not in this interval. So statistically, there has been an increase.